Alright, students, we're going to go over circles and ellipses. We're going to start with circles here. And you'll see the equation over here. It looks like the equation for Pythagorean Theorem. A squared plus b squared equals c squared. This would be 1 squared, but 1 squared is 1, so I left it as 1. Where that comes from and why it is, if you draw in a side length here, draw down a side length here, and this length here, that's where your right triangle's coming from. Now, if that's the x, and that's the y, and this radius is 1, then the Pythagorean theorem, which says a squared plus b squared equals c squared, becomes x squared plus y squared equals 1. Squared, or just 1. So that's where your formula comes from. Now, for ellipses, we're going to do something a little bit different. We're going to divide each one of these by a number. And we can put that as a squared and b squared. It's different from this a squared, b squared. It's unfortunate we use the same letters, but this is different. But what it is each one of those letters is going to do something to our shape, and we're going to see how it does. So, let's get rid of this. I'll come over here, and if you're following along on your own computer, in Desmos you would just put a divide and make that like 2 squared. And then under the y, we need to put something else different than 2. I'm going to put 5 squared. And this totally changes the shape of our thing, and it's a little bit harder to see. There we go. Now we can see it. And it's hard to see where these numbers come in. But the 2, let's take a look. On the x-axis, it's actually stretched out 2 in each direction. So that would be like the radius, except for it's stretched only 2 in each direction here, and then stretched 5 in each direction here. So take a look under the y, that's the vertical stretch. Under the x is the horizontal stretch. And this thing is longer in the vertical direction. And we call that the major axis. All right. And then the horizontal side, that's the minor axis. Okay? Because it's shorter. And we can switch those by switching the x and the y numbers. Switch the number under the x and under the y, and it'll be more stretched in the x direction. Let's try that. In fact, let's try something here. Come over here. Instead of 2 and 5, we could put whole numbers. But if we put an a here and a b here and add sliders, you can see it starts out as a circle, but then you can stretch it. The bigger the number a, the more it stretches in the x direction. That gives us a horizontal major axis. Again, major axis is not a diameter because they're different lengths. So one of them's a major axis, one of them's a minor axis. And the number under the x changes the x direction. That's right, the x stretch, the horizontal stretch. Number under the y changes the vertical stretch. Okay? And that's that. There's one other thing we're going to do to this, and it's something we've done before. We put parentheses around this thing, and guess what? When we add or subtract a number here, like h, that looks familiar, and k, gosh, we have a whole bunch of variables here. But take a look. Each one of those does something. What it is, h is a shift, horizontal, not a stretch, just a shift. It shifts the whole graph. And y is a vertical shift. It does not stretch it. It keeps the same shape, but shifts it up and down. So again, it gets confusing because there's a lot of variables there, but each one has a specific role, and once you learn them, they're not too bad. And again, h has always been a horizontal change. The k has always been our variable for, so far in our textbook. So that's not any different. It doesn't matter if you started with a parabola, a hyperbola, a circle, an ellipse, exponential equation. It does not matter. The number next to the x, written as h, is the horizontal shift. These numbers under here we talked about already. Okay, but pay attention to what size they are and which one's bigger, because that tells you which one has the bigger stretch. All right, and it's kind of similar to before, but written a little bit differently. When we had x squared, sometimes we wrote it as 1 over a, or sometimes we just wrote it as ax squared. Either way, a was a multiplier, And the value of A changed the shape of the graph. And that's what it does here. It gives you a stretch. So A and B gives you a stretch. H and K give you a shift. All right. And if you press play on these things, then you can say, okay, that H is definitely horizontal. K is definitely vertical. And you just do one thing at a time. Okay. Because if you start stretching it while doing it, then it gets really kind of confusing. But you can see how you can do some pretty cool little animations by changing it. It does a little flip there when it goes to the negative. All those things are very mathematical. There's a reason why it's doing it, but I would not suggest changing all those. I would change just one thing at a time. Say, okay, this one just controls vertical. So play around with it, have some fun with it, and thanks for watching, guys. I'll see you next time.